everyone, so welcome to our project presentation which is related with computer vision subject. So the computer vision subject is the main subject that we do this project, which is sign language detection. So our topic is alright, so it's gonna be sign language detection. Let's see on the next slide. So I would like to introduce you my group member, which is have two peoples here. So the first one is my friend is Waranat Atta Chanyakun or Pearl. And the next one is Shalisa Mikala Sam or Mikey or me here right here. Okay, so let's go to the our concept of this project. So our concept is about like the system captures the hand gesture from the webcam, process with the using media pipe, extract the key features which is hand landmarks, and then predict the corresponding sign using Keras model.5 H5 model. So our goal is to bridge the communication gap between the deaf and the hard to hearing communities and those who do not understand the sign language to make them can understand easily. So let's see on the next slide. So the next one is gonna be code explanation that you can see on the screen. So we are gonna explain like step by step that what we gonna have in this project. So the first one we're gonna have like 3 code files, which is consists of hand tracking.py. Oh sorry, hand tracking.py, collect data.py, and then test.py. And we also need to install the library. So 6 library that we need to use, which is first one is CV2, that is very important, and then math, so which is using for mathematical operation, time to tracking time, and then numpy, which is numerical computation, and then TensorFlow for loading and using machine learning, and then the media pipe, hand tracking, and landmark. And then we need to have like another model 5, which is Keras model, and the label is with Keras model. You're gonna know it's gonna be model, and then the label text is gonna show you that what is the alphabet. Yeah. So I also have the GitHub. You can go to look our code at the GitHub. This link I will give you the link under the description. Okay, so this is our Python code, which is this file that we download from the GitHub. Yeah, that we made. So we have 3 files, 3 code files that we needed. So the first one is collect data. It's the name like collect the data. So we have like how much? 7 no 6 we have 6 library, and then the last one is hand tracking, hand detector, which is another file, so I'm gonna explain later. So the first one is CAP equal to CV2 video capture, which is so initialize the webcam and then initialize the hand detector to track one hand with default complexity. So max hand, you can see the max hand is 1, or you want to 2 hands, you can just change into 2. And then the offset set the parameter is to padding around the detect hand bounding box. Bounding box, and then the size of output or image size, which is a 300 pixel, and then counter of the saving image, and join data, which is 0, and then the save interval, which is a time interval in the second between saving frame is 0.05, and then next one is last save, is track the last time data was served, is time to time. And then we're gonna create the output folder, which is a directory to the save image and CSV data. Like here, this is, so it's gonna save in the CSV, and the CSV we're gonna make a file name. CSV file name is alljoin.csv. Yes, this is the collect data when the webcam is detect, and it will gonna collect data in the folder, which is called all join CSV. And the next one is why this one why true. Do you see the why true? Yes, the why true. The cap read is capture a frame from the webcam, and if it's not success is exit the loop, and if the frame is not captured it successfully. And then the next one is the detect hand. So the detect find hand image is the detect hand in the frame and return the image with annotation, and then image white, and then a blank white image which is 300 times 300 pixel for resizing and cropping the hand regions. And then the next one is gonna be LM list, which is list and the straw hand landmark coordinate. Yes, the next one is process of the detect hand, which is if this one. So the BB box, what is BB box? This one BB box is extract the boundary box coordinate of the detect hand, and then XYWH is like adjust the boundary box with padding, and the image crop the hand region from the frames. Okay, so the next one is resize and maintain the aspect ratio, which is from image crop shape here until the image white here. Yeah, so its aspect ratio is like to calculate the aspect ratio of the crop hand regions, and then resizing like here you can see the if aspect ratio is less than 1, it's gonna go to the loop, right? And then resize image resize here. But else if it more than like here, it's gonna be like this image resize high, and then it's gonna show that image crop. It's gonna show that display the crop hand region and then resize it with the canvas. So the next one is save and the joint with the joint data image. So the first one, LMS list is contain the hand marks, coordinate, and then the time last save interval is ensure that the data is saved specific interval, and then you can see the joint data is stored to the joint coordinate in list, and then image file CV2 right image file. So save the reside in the hand image here. Yeah, and then right we're gonna see it right here. I think it's I cannot see anything. Okay, so it's CV2 I'm show image. Where is it? Here, right? Yeah, CV2 I'm show image. It's gonna like output the image and then wait. It's gonna output this. It's gonna be like display the original frame with annotation and then exit the loop when you press Q. Yeah, and then gonna release the webcam when it closes and all open CV window. This one is the first file of our project of the code. So for the next file is hand tracking, which is we use this file code to import to the from hand tracking, import the hand detector, which is this one. This code is used for hand detect and then go to collect data. So the collect data will have the webcam, and it's gonna have like a joint value when you detect. Okay, so let's see in the first line we have a CV import 3 library, which also include media pipe. Yeah, which is it gonna show you the hand tracking key features. So this one we're gonna create the class hand detectors. So this one, let's see, we're gonna have like max hand is 2, detection minimum confidence of threshold of hand detection is 0.5, and then TrackCon is minimum confidence threshold of hand tracking is 0.55, and so, and the complexity of the hand detection model is 0 or 1, so which is we have 1 here, and then we initialize the media pipe hand, which is we have like cell mode, cell mac hand we just declare here, and then we have like MP solution hands, which is a media pipe hand detection modules here, and then we have self hands here to initialize the hand detection model with a specific parameter, which is all here. This is a specific parameters, and then we're gonna drawing the utilities in here is self draw. Here the MP solution drawing utils is the utilities for drawing landmark and the connection on the image, and then we have like cell result to store the result on hand detection. Next one, we have a find hand method. So we have define hand, we have cell image and draw, which is the first one is image RGB. We're gonna convert using OpenCV, convert from image from BGR to RGB, because the image when we detect gonna be BGR first, and then we use the OpenCV function to convert it to RGB. When the cell resolve, we process the image to detect hand right here. Okay, next one. BB box here is draw the boundary box coordinate of the detect hand, and next one is the like if else of here is this one. We're gonna calculate the boundary box by finding the minimum and maximum x and y coordinate of hand landmarks here. Yeah, and then we're gonna see if draw here, if here, right? If draw self in cell MP draw landmarks is the draw the hand landmark and connection of the image right here. So we use color is RGB, right, or BGR. I think it's gonna be RGB here. And then thickness of the line is 2, and the circle radius that we're gonna draw is gonna be 3 here, and then the color here the same, and then it's gonna be like return. You can see the drawing spec is the specific colors and thickness of the landmark connection. Okay, so return to the annotate image and boundary box. The next one is depth find position, which is we have LM list, which is store the landmark position ID x and y, and then my hands variable my hands is select the landmark for the specific hands is like hand number, or here you can see here, and then next one is like for loop, like ID and ML enumerate my hands landmark. So CX and CY is convert the normalized landmark coordinate to the pixel coordinate, and then returned to the list of landmarks position. And the next one is the main one. So the main one, PT time and CT time is the variable for calculating FPS. Yeah, you're gonna see. And then cap initialize the webcam, and then detect hand complexity equal to 0. It's gonna be and then this is while loop. Yeah, main loop. So cap read, we gotta see cap read. So capture the frame from the webcam, and the next one is detect find hand image. So detect the hand and return to the annotated image and the boundary box. And the next one is detect find position image. Retrieve the landmark and the position, and then we're gonna see the if else. If LM is gonna be like print the position of the second landmarks index 1. And then CT time, and the FPS is calculate the frame per second. And then CV to put the text. We're gonna put the text, put the FPS text that I see. and then we're gonna show the display image, and then wait key, and then we're gonna have like call the main function when its script is executed. So in this code that detect and track the hand in real time using a media pipe and draw the landmark and connection on the detect hand, calculating and display the FPS and print the position of specific landmarks. So this is the hand tracking file, code file.
In this file is
test.py.
It is a file that you can test our sign language detection, so which is using the file. Okay, let's see. So the first line until the sixth line is come from this one is come from the library. We're gonna install new library which is TensorFlow, and then we're gonna import the hand detector here from hand tracking files. Okay, the next one is model, which is we download the model which is called the Keras model, which is it's over here. Yeah, it's Keras model H5, and then label, load the pre-trained Keras model from this file. Yes, you can see, and then the labels is gonna read the class label here, this one. Read the class label from label.txt, which is here, and then store them in the list. Okay, next one is gonna be like the code that open the cameras, which is have a max hand only one. And then the offset, which is this one is gonna be like create the boundary box. Yeah. And then next one is to make a while loop, which is capture the frame. This one gonna appear. Oh, sorry. So this one gonna be like capture the frame from the webcam, and if it not success, it's gonna exit the loop. If it not capture successfully. Okay, the next one is find hand and get the boundary box. We're gonna image BB box or boundary box equal to detector find hands, which is detect hand in the frame and return the image via annotation and boundary box. This one is like collect data. It's the same as collect data file. As you can see, this one until here, like it's actually it's nearly all from the collecting data, because the collecting data we need to use the camera also for, and then the key point, the boundary box. So this for this file we just add only the model that we use, the model or the outside library. As you can see that this one we use the model, so for the process, we capture the video from the webcam, which is we use this one, and then detect and track the hand in the frame, which is we use the hand tracking files, and then we crop and resize the hand regions that you see, and then classify the hand gesture using a pre-trained Keras model, and then display the process image in prediction in real time. So this is all of our code part.
So, as my friend said, we have 3 code in these projects. The first one is hand tracking.py. So let's look in the flowchart. We have hand tracking main part, which is we import the important library like CV2, media pipe, and time. After that, we set the parameters, and then we go into like the class of hand detectors class. In the hand detector class, we have 2 functions. The first one is find hand, and the second one is find positions. And then we have a function main, which is a display result. Okay, let's look in another flowchart, which is find hand. The find hand one, we start by convert the input image from BGR to RGBs, and then we process the image to detect hand using media pipe. And after that, we use the decisions to detect if the hand is detect or not. If it detect for each hand, calculate the bounding box of coordinates, and then we draw the landmark and coordinate on the image if the draw is true. and if it no, we skip it, and then we return annotate image and bounding box, and then that's all about the find hand part. And then we go to find position part. The find position part, we starting by initialize empty list of LM list to store landmark positions, and then we do the same thing that the hand already take or not. If it detect, we extract the hand landmark from specific hand numbers that we can modify by ourselves in our code, and then we convert the landmark coordinate into pixel value, and after that we append the landmark ID and coordinate to LM list. But if it no, we skip it, and after we do all the thing that say yes, we return LM list, and this is the end of find position part. For the final part is main functions or display result part. So at first we initialize variable like p time, z time, and video capture objects. After that we create a instance of hand detectors, and then we start infinite loop leading a frame from the video captures, detect the hand in the frame using find hand, and then get a landmark position using find position. And if the landmark detects, we will print the coordinate of the first landmark, and if it no, we will skip the prints. After we do all this, we calculate FPS, and then we show it in the frame of window, and that's all about the display result part. Okay, let's go to the next code, which is collect data part. After you do this software, you will collect the data part from the hand detectors. So we have a main part of hand detectors. At first we start with import required libraries, and then we initialize video captures and create an instance of hand detectors to detect the hands, and then we set variable of like offset, image size, counter, save interval, last save intervals, and then we create a folder with and the name of folder. If it's not accessed, you can change the name of folder by coding. Anyways, we define the CVS file as an object, so we can collect the hand landmark point in number also. And then after that we go to the main loop part, because this is all about the initialize part. So the main loop part collect data. So we start by reading the frame of the video captures. If the frame is read successfully, detect hand in the frame using detectors hand find hand and create a white image. And then after that we initialize an empty list LM list, and we check is the bounding box is detect. If not, if yes, we extract the bounding box coordinate and then add a padding to the bounding box, crop the image using padding bounding box, and then we calculate aspect ratio for crop image, and then get landmark position using detectors find positions. And then we check another thing is the height is more than 1. If it yes, we recite it, and if it the base on height is recite a base on a height, but if it no, we recite a base on a line, so the data will like at the same pixels at the same value, like and then after that we center the resite image on the white background and display a crop image and white image. And then we detect are the landmark detect and save interval pass. If it's yes, we instrument the counters and then prepare join data to the CSV file, and then we save the join data to CSV file, and then save what image to image counters.jpg, and then we print confirmation message. So another thing is we display the original frame with hand landmark, and then we check if is the key Q is pressed. If it's yes, the loop will break, but if it no, we will continue the loop continuously. So for the last part of this flowchart, we release the video capture object and close all CV windows, and that's end of the programs. So the last part, which is the test code main part. So we use the model that we already trained on the teachable machines, and then let's start the flowchart because we don't do any prediction in here, so we use the model. Anyways, we import the required library, and then we load the train Keras models, and then we load a label of label.txt. We create an instance of hand detectors again and set a variable of offset, image size, counter, save interval, last save interval, like the same things. And then let's see at the test code main loop part. So for the test code main loop part, we start by the infinite loop, and then we read a frame from the video captures. If the frame is read successfully, detect a hand in the frames, and then using a detectors.find hand, create a white image, and then instant an empty list LM list. And if the bounding box detects, we extract the bounding box again and pending to the bounding box, crop the image using the pending bounding box, and then calculate the aspect ratio for the crop image, and then we get a landmark using detect find position. And the same thing we do is height more than wide, so we resize based on height. But if we know we resize based on wide, then we center the resize image on the white background, resize the image into 224 multiplied by 224, and then we expand the dimension of the image for the model input. Use the model to predict the class of the hand gestures, get the prediction class index and corresponding labels, calculate the confidence score for the predictions, and then we overlay the prediction labels and confidence score on the original frames. We display the crop and white image, and we display the original frame with prediction and bounding box. And we can quit the program by check is the Q key is pressed. If it's yes, it's break the loop, but if it's no, it will continue the loop infinitely. So for the cleanup part, we release the video capture objects, close all OpenCV window, and that's all. That's all about the code part and flowchart that we need to know. Let's start testing. We will start with Y, which is very accurate. You can see that. W. Then we can go by like K, like this, and then we can go like it should be V. Yeah, let's get to the right position to get some alphabet, right? Like here, this one should be A, but let me move around a bit, and yeah, we get an A. And you can see there's some confusion with E because E is a lot like A. Right here, we have C, like this. Yeah, we have H, like this, and we have Q, which is very accurate also, and we have L, that also accurate. There's some glitching between each alphabet because we don't use that much data. Each alphabet we have around 100 data, and you can see that there are some point that very look alike, like V and K. There's and this one should be D. Yeah. So as I say, they have some glitch. This one should be R. Okay, these have some glitch between the alphabet because like we use not that much data, but I think we still can develop it as it should be, like 100 data per like alphabet. But as you can see, does take a lot of time to run right now. So thank you.